Good morning, my dear student. I am Dr. Suvadra Das from University of Engineering and Management Kolkata. Today I will discuss some practical session related to engineering chemistry. Today my topic of discussion is determination of hardness of water present in the given sample of water. So first of all, we want to know what is hardness of water. Suppose you are taking some soap, you are taking water and you want to wash your hands. But instead of forming leather, if it is formed an insoluble card, then you can say that the water you are using is hard water. So it is the soap destroying property of water. Why it is coming? It is coming due to the presence of different salts like bicarbonate salts, sulfate salts and chloride salts of calcium and magnesium. Now there are two types of hardness. One is temporary hardness, one is permanent hardness. Temporary hardness comes due to the presence of bicarbonate salt. Why it is called temporary? Because by simple boiling, you can eliminate this type of hardness. Because if you boil the temporary hardness water, then the bicarbonate will convert it to carbon dioxide and you will get a normal water. So you can remove this kind of hardness by simple boiling. So it is called temporary hardness. And permanent hardness is due to the presence of different sulfates, nitrates, chlorides of calcium and magnesium. And this kind of hardness you cannot remove by boiling. Some special kind of water treatment is necessary. We measure hardness in equivalent, in milli equivalent, in terms of milli equivalent per liter, and 1 milli equivalent is equal to 50 mg of calcium carbonate per liter. Now we are going to use complexometric titration method for determination of water hardness. Here we will use a chelate compound, that is disodium EDTA salt. Disodium EDTA salt reacts with calcium and magnesium ions, which is the responsible element for the hardness and form complex compound. So thus it is giving different color. Now what is our objective? Our objective is to estimate the total hardness given in the sample water. So total hardness of the water is considered due to the presence of different calcium and magnesium salt. It may be sulfate, it may be chloride, it may be bicarbonate. Now both calcium and magnesium salt first will form complex with an indicator. First we will take some sample water, like 10 ml of water we will take in the conical flask. Then we will add some buffer solution, ammonium chloride, ammonium hydroxide solution we will use as buffer solution. Why? Because we have to maintain the solution pH at pH 10, because complex formation is only possible at this pH. So when we are going to add indicator, the indicator name is eriochrome black tea. What will happen? The sample water will contain calcium and magnesium ion, right? Now you are adding eriochrome black tea indicator in that solution at pH 10. Then first it will form complex. The eriochrome black tea will form complex with calcium and magnesium ion. Now next step is the titration with disodium EDTA salt. Now disodium EDTA is a stronger chelating agent than eriochrome black tea. So what it will do, as it is a stronger agent, it will replace the EBT and it will itself form complex with calcium and magnesium. Now EBT will remain free in the solution. The free solution of EBT will give color as blue. So the complex solution of EBT and calcium magnesium is, the color of the solution is wine red. So after adding of the indicator at pH 10, you will get wine red color. But when you will add EDTA solution to that water sample, EDTA will form complex and it will make EBT free, that is indicator free. The color of the free indicator is blue, so you will get blue color at the end point. See, this is the total reaction. First, calcium and magnesium will form complex with EBT. It is giving calcium magnesium EBT complex. The color of the solution is wine red. In the next step, when you are titrating with EDTA, it will form calcium magnesium EDTA chelate complex and the indicator will become free. So color of the free indicator is blue. So this is the structure of the disodium EDTA salt. This is the structure of the eriochrome black tea. This structure you have to remember. And this is the color of, this is the picture of the solution, how it looks like. It is the color of the solution, that is wine red. after the addition of EBT to the sample water. Now after the titration with EDTA, you will get the blue colored solution. So what are the chemicals required? Chemicals required here are ammonium chloride, ammonium hydroxide buffer, EBT indicator, disodium EDTA salt, and water sample. First, you have to pipette out 20 ml of sample water in conical flask. Then you have to add ammonium chloride, ammonium hydroxide buffer to bring the pH at 10. Then you have to add 1 pinch of EBT indicator to the mixture. Then the entire solution will colored as wine red. Then you will titrate this solution against standard 0.01 molar disodium EDTA solution. It is taken in the burette. So at the end point, you will get wine red to blue color change. Finally, you should calculate the water hardness. This is the observation table. At least three observation you have to take. You can take more than three, more than at least 5 observation you can take also. This is the volume of water sample 20 ml we are taking here. So it is the initial reading, it is the final burette reading. From the difference you will get the burette reading, and the mean volume of sodium EDTA you will calculate from the 3 reading. Total water hardness you have to calculate by using this equation. Equation tells that volume of EDTA, that is you are getting this value from your burette reading. Strength of EDTA, it is given 0.01 molar. 100 into 10,000, 100 into 1000 is your conversion factor. You have to convert it ml to the liter. So you have to multiply by 1000 divided by volume of water sample. So you are getting the value as mg per liter or ppm, parts per unit. That is how many parts are present in million parts of water sample, which is called parts per million. So now I'll show you how we are going to do the practical itself. See here, you have to first choose the hardness test. Then so you are choosing hardness as your test. Then you can take either well water or tap water or sea water. Say we are taking here the tap water. Now volume of the titrate, that is water samples volume is 10 ml. Here we are taking 10 ml. You can change it also. Speed of the titrate I am changing little bit. Say I am getting it 0.2 ml. Molarity of the titrate you have taken 0.01 molar. So basically you are using titrant as EDTA. Your titrant is UDTA. Titrant is those substance which you are taking in the burette. So it is EDTA. Titrant used till now it is 0 ml, and your indicator is heliochrome black tea. So you are getting wine red color over here. Now you are starting titration. When it turns blue, I'll stop the titration over here. So now titration is going place. When it turns blue, then I'll stop the titration. Till now it is wine red. So let us see when it changes its color. So the titration is going on. You set all the parameter. You are using virtual lab for this experiment. So it turns blue. So I am stopping the titration. Now see, titrant used is 1.5 ml. So I am going back to my original slide. From here you are getting the volume of disodium EDTA you are required for the titration. So I am returning back to my original slide. So here you will put the value you are getting from the virtual lab. Strength is 0.01 molar you have taken after multiplying by the multiplication factor and dividing the whole thing by volume of water sample, you will get the hardness as ppm. Thank you all for your patient hearing.